This is the fourth section of chapter 1, algebraic expressions, and this section is on negative and fractional indices. So in this section we're going to be extending what we know about indices, powers, exponents, and extending it to powers which are either negative or fractions. Now we've already got some rules from a previous section here, so I'll just write these down for recap. Now we'll look at what the rules are for these negative and fractional powers. So the first rule is, if we have a negative power, the way that we evaluate it, or we say it's the same as 1 over that base to the positive power. Now this rule is not negative going to the front. I've seen that a lot with students where they will say x to the negative a is negative x to the a. So there's never a negative there. That power doesn't just move to the front like that. Okay, so it's 1 over the positive power. I'll do an example like I did when I did these before. So for example, if I had 5 to the power negative 2, that's the same as 1 over 5 squared. So there's no negative in front of that, and I could change that to 1 over 25, for example. So I could go all the way and say, right, it's 1 over 25. Secondly, when we have a fractional power like this, the number at the top of the fraction is the power, and the number at the bottom is the root. Now we can apply these rules in any order. So I could take my base and do the power of that base, and then find the root of that. So work out the power first, then find the root of that. Or, and this is the one we're most likely to use, find the root first and then the power second. The advantage with using this method, the second method, is that you'll end up with a smaller number when you find the root of a number, which you can then find the power of. I'll give you an example. So here I want to find out or evaluate 4 to the power 5 over 2. So if I did it the way where I work out the power first and then the root, I would have to work out what 4 to the power 5 is, and then find the second root of that, which is the square root. Now, without a calculator, that's going to be hard work, working out what 4 to the power 5 is, and then working out what the square root of it is. But if I were to do it the other way and do the root first, so I find the square root of 4 and then find the power, this is much easier because the square root of 4 is 2, and I work out 2 to the power 5, so that's going to be 2, 4, 8, 16, 32, easy. That can be done quickly, but this way it's going to be more difficult. So I would always suggest that you work out the root first, the second method, and then the power second. Now we can combine the rule for fractional powers and negatives and say, right, if we've got a base to a negative fractional power is equal to 1 over that base, same base, to the positive fractional power. So this combines rules 1 and 2. And lastly, one rule which I've put over here, which we haven't used before, and that is any base to the power 0 is always equal to 1. So we can combine these new rules here with the previous rules that we used before. Example 9. Part A, what we want to do is to simplify all of these. So we have x cubed divided by x to the minus 3. Now when we've got a division, what we do is subtract the powers, so it's going to be 3 minus negative 3, so we need to be careful. That's the same as x of 3 plus 3, so that becomes x to the power 6. Part B, we have x to the power half times by x to the power 3 over 2. So what we need to do here is add the powers. So it's going to be x to the power half plus 3 over 2. So basically a half plus 1.5, that's 2. So we get x to the power 2. C, x cubed, and that is raised to the power 2 over 3. So to evaluate this, it's going to be 3 times by 2/3, 3 times by 2 over 3. And if we do that, 3 times by 2/3 is just 2. So this also becomes x squared. Moving on to D, we have 2x to the power 1.5 divided by 4x to the power negative 0.25. Now, I never like working with powers which are decimals unless I really have to. So on a question like this, my first step is going to be to change those powers to fractions. 1.5 is 3 over 2. You don't have to do this, but it's just my preference. And then 4x, and then minus 0.25 is the same as negative 1/4. And then I'd work from there. So I've just highlighted some of the answers so we can see them. I'll do the same with this one. So now I'll use my rules for powers. So here I know that I need to divide the numbers. 2 divided by 4, 2 over 4, which is a half. And then x, and I need to subtract the powers. So this is going to be 3 over 2 minus negative 1/4. Let's write that down because we're dividing. So it's 3 over 2 minus negative 1/4. And we'll work that out. So that'll be a half x. That'll be to the power 7 over 4. Now you could have left it as decimals and worked as decimals. I just prefer working with fractions. Now you could also write this answer as x to the power 7 over 4 over 2. Same thing, just a slightly different format. So we'll just highlight that as our answer, or in this form, and we'll move on to part E. So part E, we have the cube root of 125 x to the power 6. Now, when we've got a product to a power, and we have got a product here to a power, we apply the power to both of these things. So we need to find the cube root of 125 and the cube root of x to the power 6. Now the cube root of 125 is 5, because 5 cubed is 125. And the cube root of x to the power 6 is x squared. So our final answer is 5x squared. That's what this one simplifies to. Now you might be wondering, how did I know that the cube root of x to the power 6 was x squared? Well, there's a couple of ways. First of all, I could think of, well, what number times itself 3 times will give me x to the power 6? Well, x squared times x squared times x squared will give me x to the power 6, so the cube root must be x squared. Or you can think of the cube root as being the same as to the power 1/3. So if I do x to the power 6 to the power 1/3, which is the same as finding the cube root, I multiply the powers, so that's going to be 6 times 1/3, and a 6 times 1/3 is 2, so x squared. So either way, we can find the cube root of this. And the last one, f. So we have 2x squared minus x all over x to the power 5. Whenever we have terms over a common denominator, what do? We split them up. So we've got 2x to the power, or 2x squared, not power 5, over x to the power 5, minus x over x to the power 5. So now we can go about simplifying that. So the first one we subtract the powers, so it's going to be 2 minus 5. So that will be 2x to the power negative 3 minus, and here we will have 1, or x to the power 1 minus 5, that'll be x to the power minus 4. So we can write it like this. Another way we could write our answer is we could write it as 2 over x cubed. That rule to do with negative powers, 1 over the positive power, so you could write it like that. And then the second term you could write as 1 over x to the power 4. It all depends how you're feeling or what the question asks. You could write your answer in either one of those two forms. They're equivalent and they are both correct. Example 10. We want to evaluate all of these, which means we want to work out what they are. So as a reminder, when we see fractional power, we want to do the top power is the power, the bottom one is the root. So if you see, let's say, a power of half, because the power is 1 and the root is 2, that's the same as just doing the square root. That's the quick way. We don't need to do power 1, that's not going to change it. If I see, let's say, x to the power third, that will be the cube root, because you do cube root and then you do power 1. And in general, if I've got x to the power 1 over n, it will just be the nth root of x. Obviously, if that top number isn't 1, then we also need to find the power as well and work out that power. So we'll do the first one, a, 9 to the power half. The root is 2, the power is 1, so that's just the square root of 9, which is 3. Moving on to b, we've got 64 to the power a third. So the root is 3, the power is 1, so that's the same as just doing the cube root of 64, which is 4. These are roots that we should know. C, 49 to the power 3 over 2. So this isn't just a plain square root or cube root. What we're going to do, we'll do the root first. So we're going to find the square root of 49, and then whatever that is, we're going to cube it. So the square root of 49 is 7, and we need to do 7 cubed. Now 7 cubed is 343. That's a useful one to remember. If you don't, you can always use your calculator for that one. And the last one, D, we have 25 to the power negative 3 over 2, which is the same as 1 over 25 to the power 3 over 2. Remember, it's 1 over the positive power. So it's going to be 1 over the square root of 25. We do the root first because it's a 2 square root, and that's going to get cubed. So that's 1 over the square root of 25, which is 5, and then that's going to get cubed, and 5 cubed is 125. So our final answer, 1 over 125. So first answer 4, second answer 343, and the last one 1 over 125. Example 11. Given that y is equal to 1 over 16x squared, express each of the following in the form k x to the power n, where k and n are constants. So all we need to do with each one of these is replace y with 1 over 16x squared. So I'll just highlight those bits. So y in both of these is going to get replaced with 1 over 16x squared. Then we use the rules of indices to simplify. So y to the power half will become 1 over 16x squared to the power of a half. Now when we have a product in brackets and it's to a power, we apply that power to both parts of that product. So it's 1 over 16 to the power half times by x squared to the power half. Now remember, power half is the same as square root. So what we do is we find the square root of 1 over 16, which means we square root both the numbers in the fraction, square root of 1, square root of 16, so it's a quarter. And we square root x squared, which just becomes x. So it's just a quarter x, which we can also write as x over 4. And we can write down the value of k and n in this case. So k would be a quarter, and n would be the value of 1. So we'll just highlight that before we move on to the next one. Next one we're going to do in the same way, in that we are going to just replace y with that expression that we've given in terms of x. So b, we have 4y to the power negative 1. So that becomes 1 over 16 x squared to the power negative 1. So you should now be able to do exercise 1D on pages 11 to 12 of the textbook.